All right, for this video, we're going to talk about what absolute value is and how to graph it. Absolute value is a number's distance from 0. So if I have -5, I'm over here, I'm still 1, 2, 3, 4, 5 away from 0. So absolute value is always going to come up as a positive number. Absolute value of 0 is nothing away from 0, so it's still going to be 0. Absolute value of 42, if I'm way up here at 42, I'm still going to be 42 away from 0. The direction doesn't matter. Absolute value of 8, going to come out as positive 8. Absolute value of -23, if I'm -23 in this direction, I'm still 23 away from 0, so it's that distance. Direction doesn't matter. -2,439 is going to have an absolute value of positive 2,439. So main point there, whatever comes out of the absolute value, once you take the absolute value, should come out positive. So when we graph the absolute value, the parent graph, the most basic value of this is y equals the absolute value of x. So if I put the absolute value of 0, I'm going to get 0. If I put the absolute value of 1, I'm going to get 1. Absolute value of 2 is 2. Absolute value of 3 is 3, so on and so forth, infinitely in that direction. Now, if I go into the negatives, the absolute value of -1 is a positive 1. Absolute value of -2 is positive 2. -3 is positive 3, so on and so forth in the other direction. And I can't draw a straight line to save my life. So what we have here is the parent graph of the absolute value. It's always going to look like a V, whether it's upside down or not. And it's without any changes, it's going to be at 0, 0, going out 1 and up 1 in both directions. Now we're going to start changing that with various transformations of it, but I want to refer to some points here. This point right here is it's the vertex. It's also known more generally as the locator point. And as we move on to the next screens, it's going to be HK. So I'll explain that in a moment. All right, so we have this graphing form of an absolute value graph. I'm going to explain what these different letters will do to this graph. And then in the next ones, I'll do some examples. And then if you want to stick around, I'll explain why those work the way that they do. So if you have a change in A, if A is greater than 1, then that absolute value graph will get skinnier. If A is between -1 and +1, meaning it's a fraction between -1 and 1, it's going to get fatter or wider. If A is negative, it will flip the whole thing over. And I'll say flip vertically. Now, x minus h inside of those absolute value lines, the minus is often what confuses people, but the h is going to move it left or right. So that's going to move the vertex left or right. And the confusing thing about this is that it moves it in the opposite direction of what you'd think. Like an x minus 2 is going to move it 2 to the right, whereas an x plus 2 is going to move it 2 to the left. And I'll explain that in a later one. And then K, I need a different color, outside of the absolute value graph is going to move that vertex up or down. And that's going to be in exactly the direction you think it's going to be. So that H is opposite of what you'd think. And the K is exactly as you would expect. All right, so let's do an example. So I have y equals absolute value of x minus 4 minus 2 outside of the parentheses. This x minus 4, here's what I want you to notice, x minus, x minus. So this part is part of our graphing form. What's in place of h is 4. Let's do that different color. And in place of k, we have minus 2. So k is going to be minus 2. I think my color coding is not making any sense. So you can ignore the color coding. So that's basically going to take, so my HK point or my locator point is going to be at 4, negative 2. So what that does, it's going to take this vertex and just going to move the whole graph over 4 and down 2. So there's been no change in the A value, which would make it skinnier or fatter, so it's still going to go out 1 and up 1 in both directions. So I'm going to go right 4, down 2 to graph my new locator point. Then I'm going to go out 1 and up 1 in both directions to make my graph. And I really only need these 3 points to get that going because the pattern in an absolute value graph doesn't change as it goes out. That was really, really bad. All right, there you go. And so that is my transformed graph. Do another example. This one is of the absolute value graph for 2x. So I'm going to just kind of lightly put in the, that's really lightly, the original absolute value graph. Make that just a tad darker. So starting at 0, 0, going, I cannot make a straight line. Out 1 and up 1 in both directions. What's going to happen with this A, anytime with any of our graphs really, what the A tells you is from the locator point, you're going to go right 1, and instead of going up 1, you're going to go up 2. And because the absolute value graphs are symmetric through their HK point, through their locator point, we're just going to keep going up 2 and over 1 in both directions. So this one's going up twice as fast. So that's how the A value is going to impact that. If it was 1/2, it would be going over right 1 and up 1/2. So we'd have something like that. So yeah, that's how A impacts the graph. Now we have a negative in front for our A, and we have a change in the locator point. So I'm going to do the locator point first. X minus h, so this is x plus 3, which is essentially another way of writing x minus, because that's what we have there, a negative 3, and then plus 4. That whole thing's going to be negative. So my locator point, my HK, is going to be negative 3, 4. So it's going to take that original graph that starts at 0, 0, and we're going to go negative 3, 4. Nope, just kidding, negative 3, positive 4. So it's going to be up here is going to be my locator point. And that negative out in front, that's a negative 1 for A, means instead of going up and out, I'm going to go down 1 and out 1 in both directions. So that is my transformed absolute value graph. All right, so now if you're willing to just accept what HK does and how it moves it left and right opposite, then you're good to go. This part, I'm going to explain kind of why that works. And it has to do with our x-intercept. Our x-intercepts, all along the x-intercept, y equals 0. So what we're looking for inside here is whatever is going to make y equal 0. So if I have the absolute value of x plus 3, what's going to make that 0 is going to be where x equals -3. And so instead of moving it right like we might expect, it's going to move it left. So what I'll do is I'll show you some of the math on that. So we'll do the points -5, -4, -3, -2, -1, and 0. So this is going to take a little while, so you just have to be patient. So if I do the math here, it's going to be -5 plus 3, which is equal to the absolute value of -2, which is equal to +2. So that's the point -5, +2. Do that with -4, so -4 plus 3 is going to give me -1. Still haven't taken the absolute value. Now I take the absolute value to get 1. So -4, 1. -3 we know is going to give us 0. Whoops. -3 plus 3 is the absolute value of 0, which is just 0. -2 plus 3 is going to give me +1, which has an absolute value of 1. So -2, 1 is that point. And you can guess kind of the pattern here. -1 plus 3 is 2. We're still in the absolute value. +2 for that. And then 0. 0 plus 3 is going to give me 3. Still in the absolute value. Take the absolute value, we're going to get +3. So we can see if we actually do all that math that that locator point, basically, if we kind of write this differently, this has +0. This gives us an HK, or locator point, of -3, 0, which is right there. So hopefully that helps explain why the inside the absolute value is the opposite of what you would think. That works with pretty much all the graphs we're going to work with eventually. But there it is. So I'm not going to go through the whole table. We'll just do one more example here. This is going to have an HK of 2, 5. So we're going to go right 2, up 5, make our locator point. There's been no change in A, so I'm just going to go out 1 and up 1 in both directions. And that's all I got for you. Hopefully that helps with transforming absolute value graphs or finding the equation of a transformed graph. Yeah, have a great day.